working as assistant professor in UIIT, Himachal Pradesh University. He is also pursuing his PhD from NIT Hamirpur. Please give a huge round of applause for Mr. Pradesh.
Good afternoon. First of all, I'm very thankful to Professor Mahavir Singh sir for giving me opportunity to present my work in this conference, and my very good friend Dr. Kuldeep Singh ji, and my supervisor Dr. Jayaprakash sir. I'm very thankful. Before starting my oral presentation, let me introduce myself briefly. I'm assistant professor at Himachal Pradesh University. I'm presently on study leave. I'm pursuing PhD from NIT Hamirpur. This is my brief introduction. And today I'm going to present on Janeno-based photocatalysts, a sustainable approach to water decontamination. As was you can look over this table, there are bisleri bottles kept over there. Why do we need such bottles? Earlier, 20-30 years back, we could directly drink water from the tap water or something else. Why do we need such mineral bottles? Answer lies because water is getting polluted and water is getting contaminated. And if water is getting contaminated, we of course need decontamination technique or purification which can treat water and make useful for our drinking purpose. So I will briefly discuss about the decontamination using Janeno-based photocatalysts. Although sir has in very detail discussed about what catalyst and what is photocatalysis, I'll just throw some light and just make crux of sir's presentation. So my presentation will I have broken into three parts. Introduction to water contamination, what is the problem. In this slide I'll discuss about what is the problem and what is the possible solution. And what is photocatalysis and what are photocatalysts, why it is a better technique over other conventional water purification techniques. Janeno, one of the promising material, one of the best photocatalysts. And limitations, of course there are some limitations, nothing is perfect. There are some limitations with Janeno, and these limitations, how to overcome these limitations, there are some strategies. And second part of the conversation would be my original work, Janeno and silver dope Janeno, how doping has affected the photocatalytic degradation activity. This is the original work and published in the paper Emergent Material. Last part of my talk would be Janeno and Geo, where presently I am looking to work Janeno and Geo nanocomposite. In this, I'll talk about how heterojunction formation would enhance photocatalytic degradation activity. So let us start. Introduction. As you all know, industrial based every year. इंडस्ट्रियल वी कैन जो हम कपड़े पहनते हैं, जो इसमें कलर करते हैं डिफरेंट ये सारे सिंथेटिक डाइज का यूज करके होता है. और जो डाई जो हमारी टेक्सटाइल इंडस्ट्री है, व्हाट दे डू, टेक्सटाइल एक्चुअली इंडस्ट्री इज सिचुएटेड वेरी नियर टू द वाटर सोर्स. So what they do, they actually discharge water directly into the rivers or any other source. So actually what is happening, water is getting polluted, and you know dyes contains very harmful chemicals which are very dangerous for our health. And second category of pollutants are pharmaceutical based, like antibiotics. That when we fall ill, what we do, we usually go to a doctor, and the doctor will prescribe a medicine or that bacterial component will be there. And secondly, I think if there is anyone from medical background, they would also believe that our human body has got a very limited absorption capacity. I think 20-25% maximum our human body has a capacity to absorb these medicines. But where will the rest of medicine go? If we take a medicine, 20-25% will be absorbed in our body or blood. Where will rest 70-75% go? That will be excrete, and that finally goes to septic tank. And when we treat that water with other conventional techniques, so these techniques usually do not treat bacteria. These were some limitations of conventional methods, and I'll talk about why this photocatalysis is best to even degrade bacteria, very harmful bacteria. And the third category of pollutant is agricultural waste. You know, farmers in India, 80% of the farmers are illiterate, and they exactly don't know how much fertilizer is to be applied on a soil to enhance its productivity. What they do, they apply huge amount of fertilizer. And again, as human body, soil has got limited absorption capacity. So if suppose we have applied X amount of fertilizer, pesticide and insecticides over a crop, so if soil has less than X capacity, where will that excess amount go? That will go with the runoff water to rivers, streams, and different categories, and they will again decontaminate the water. So these are categories of pollutant affect aquatic life, and these pollutants are also found to be carcinogenic, mutagenic, and genotoxic. They eventually mutate the genes and are also found to be carcinogenic or cancer causing. Sustainable development, you know that we have 17 sustainable development goals to be achieved by the year 2030. And these goals, one of the goals, sustainable development goals, says to improve water quality by reducing pollution, eliminating dumping, and minimizing release of hazardous chemicals and materials by 2030. This is the one of sustainable development goal, and without having efficient decontamination technique will not be in a position to achieve this particular goal. So we actually what do we need? We need an efficient water purification or decontamination technique so that we'll achieve this sustainable development goal number 6. Let me briefly discuss about photocatalyst, what are photocatalysts and what is photocatalysis. I'll just throw some light on any, most of you are also from science, chemistry background, you have learned about what are the photocatalysts. Catalyst, first of all, catalyst are any material, those which enhance the rate of a reaction.
5 minutes में करना है conclude.
Okay.
Oral has to be completed within time.
Okay.
Yes.
I'll be fast.
Yeah.
So photocatalyst, photo is attached to with the catalyst. Photo is a light. Photo means light. But light is effective in treating pollutants which are difficult, as I mentioned, to break down using conventional water techniques like Phantom reagents or any other many methods. This method uses a simple reactor setup, and specialty lies in the preventing secondary pollution environment, and is also environment friendly as it uses the sunlight, because sunlight is available and available free of cost. So this is the specialty about photocatalysis. It follows one of the principle of green chemistry. Zinc oxide, where I am targeting. Zinc oxide is a wide bandgap semiconductor having bandgap 3.37 electron volt, having large excitron binding energy, which makes it very special. It exhibits very photocatalytic activity under UV light. So it is only UV active. Low cost, chemical stability, eco-friendliness further enhances its potential for practical applications. High surface to volume ratio, surface defects, oxygen vacancy makes it a foremost choice over many other photocatalysts like TiO2 as mentioned by the sir and many others. Mechanism I'll briefly discuss, although it has been discussed by sir. The photocatalyst, when light is incident on this is figure, when light is incident on ZNO, then what they do, electrons are excited from valence band to the conduction band. So they will leave a vacancy in the valence band. That vacancy is known as hole. In this manner, holes and electrons are created, and these electrons and holes, when they react with they comes to the surface of the photocatalyst, they react with the oxygen and water. They makes free radicals like O2 minus and OH dot. When these pollutants, last reaction, when these free radicals react with the water, pollutant, sorry, they actually decompose pollutant completely, and we finally got a very byproduct which is not harmful, and the entire process is called mineralization. Limitations, wide band gap, limitation with ZNO, wide band gap, as I told, it is only UV active, and UV has just 4 to 5% in the solar spectrum. So what we need to do, we have to increase its absorption range, we have to go to the visible, and so we need to modify ZNO. This is one of the limitation. Fast electron hole recombination. Actually, what electron and holes are forming these reactive oxygen species, which are very active, reactive, and if they get recombined, so will not generate much of the electron and hole pairs. Photocorrode the ZNO material, and agglomeration. When we go to the nano level, then these nanoparticles started agglomerating, and actually totally reducing its total surface area, which is not good. Various strategies: doping with metals, non-metals, and metal deposition, morphology change, defect engineering. We can create a defect which, and defect can act as a trapping center for electron. Electron will be trapped, and we can prevent electron hole recombination. And coupling, last one is a coupling with other semiconductors. This is the ZNO and silver dope ZNO for degrading methylene blue. I have taken methylene blue as a targeted pollutant. This is a comparative study. In this, we have synthesized a soap nut. In Padi, we call it a retha. And due to different phytochemicals present, they are acting as a reducing and stabilizing or caping agent. Structural and morphological properties, these are XRD and SAM images. I'll not go much into detail because I think most of the audience is from social sciences. Just these characterization techniques confirms the synthesis of ZNO and silver dope ZNO, and they show flower-like, SAM shows flower-like morphology which is free from impurity. Optical property shows with the silver doping, we reduce the band gap. As we reduce the band gap, we go to the visible spectrum, so we can absorb a visible photon also, which is good, which further enhances photocatalytic activity. Photocatalytic methylene blue degradation. This activity shows, as you can directly look at over here, the study found that AG, silver dope ZNO, degraded 98.33% of the methylene blue in 90 minutes. And pristine ZNO, it degraded 96.06% in 90 minutes, which shows that silver dope ZNO has a better photocatalytic degradation efficiency. And one of the area where promising material is another, as mentioned by the sir, is we can make a composite of ZNO with graphene oxide. Graphene oxide has got a special property. Graphene oxide is nothing but when we oxidize a graphite, it forms a graphene oxide, and it contains various oxygen functional groups. and it makes it unique because it behaves like a semiconductor. When we make a heterojunction with galeno, then synergetic effect. Galeno acts as a photocatalyst and GO acts as an electron capturing, or they actually accept electron which further reduces the electron hole recombination. Improved surface area. Graphene has got a very good surface to volume ratio, broad spectrum absorption, because graphene itself, its band gap itself lies in a visible spectrum, and versatile. It can be doped, or we can make composite with various other materials. Stability, compatibility, and we know that graphene is carbon-based material, so there is no any toxic impact. Environmental compatibility is one of the factor, and this is all about my slide. Where this is Jadano Geo is a material where I'm working on. Thank you, DAV College Chanda. This is what I summarized in a very short time. I'm very thankful to my supervisor, Professor Mahavir Singh sir. I was one of his students during MSc. And my collaborators, Dr. Ritesh, Pankaj Thakur, Deepak and Sahid, and my good friend, Dr. Manish. We used to discuss many research ideas together. Thank you all. Thank you much.